or actually I can say it myself. Hello YouTube, welcome to the video today. We forgot to record the beginning of the lecture, so in the beginning I did talk about the test and did a quick overview. So if you want to see that, check out twitch.tv/sniperjf, or actually it's up there. Yeah, it's up there. And then look at the beginning of the lecture there. Okay? That's if you're taking the test next class. Hello YouTube. All right. But yeah, let's talk about new material. So this virtual function stuff and whatever we talk about today is not on the test for sure. The cutoff was the pointer stuff. So, you know, it's still going to be on the next test, and it's still going to be useful information that will strengthen your knowledge in pointers and memory. But it's not mission critical that you like understand this right now. So sit back, relax, and enjoy the ride. Okay. So we have been talking about dynamic allocation, and basically we did this 2D, 3D array dynamically allocated object. That's cool. Dynamic allocation is cool. You know, still you're not going to use it in the real world. You're going to use a vector and like call it a day unless you're doing some crazy optimization. But it's very important to understand how it works because you know, you have to understand, like I was saying the same thing in Trello too, but like you have to understand the tools that you use so that you can use them efficiently and effectively, right? If you don't understand the tools, you don't understand what's happening. If you don't understand how memory works, then you can use memory, but you're not going to use it to its maximum. And you might make things that totally unoptimize the code, such as like what was happening in assignment 1, that example that is just going to live in infamy now. You know, they were doing a function call, and every time they did a function call, they passed an array of size 50,000. So of course that's killed the code speed. Remove that, and like optimization just went over the roof, like just for something so trivial as not removing, but literally switching from passing by reference to, passing by value to passing by reference. So like, you don't know that unless you of course learn all this stuff later down the line. So there's a reason for that. However, today's discussion on dynamics and virtuals are like, this is real stuff that you would use versus like dynamically allocating stuff. So, which you might not use that much because you can just use a vector. So, first, let me introduce you to the magic of abstract classes and virtual functions, okay? So, right now, when you've been making your classes, you have your class, you have a constructor, you have your fields or member variables, which I don't really have one here. Actually, no, I do. Yeah, I have this one. And then you have your destructors, right? And I talked about the risk of something like this with the shallow versus deep copy, which was the last thing we talked about, and how you were making a shallow copy, and that you need to make a deep copy. You need to use something like a copy constructor, which we'll get to when we do operator overloading. So we talk about all these things, and you kind of get a basic idea of how to use pointers and classes, right? But what if the class itself is a pointer? Okay? What happens if I make a object, literally like object A, into a pointer? I can do that. You know, I can go ahead and say something like A star equals new A. And what I'm doing now is I'm making an object, this A object, and I'm storing it in a pointer. And remember, pointers, you have to put the data type of the pointer, and then you have to put the identifier, and you put in the middle the asterisk. So instead of saying like int asterisk ptr, I'm saying class A asterisk, and then just the variable name, which in this case is just A. And it's being assigned a new A. So the only difference now is that this object A is going to live on the heap instead of the stack, so it's a dynamic object, etc., etc. We know that when we access variables now, we can use the arrow operator and so on. Okay, very cool. Let's talk about what happens when we do inheritance and pointers, okay? For that, let's do it with pictures first, okay? So let us say that we have the following sort of scenario. We're going to have two classes, a parent and a child class, okay? Superclass and subclass, whatever you want to call it. So we're going to call class A and class B. That way we can, update our code. Class A has some code, and class B is going to inherit class A. So yeah, some good review for inheritance, right? Because that's in the test too, so that works out. So remember, you always got to put public, private, or protected here, unless otherwise it'll default to private. And you got to put it in front of each one if you do multiple inheritance. Although here we're just going to do like a single inheritance. Okay? So, like I said, even though this stuff is not on a test, like virtuals, inheritance is. So it's a good review of that. Okay? So, class B inherits from class A. Of course, these are not exciting right now. There's not particularly anything useful there. But, we're going to make a pointer in here. And I'm just calling it PTR because that's what I currently have from the last example. So I'm literally just kind of copying that. So you have a pointer here. And then we have a constructor that's going to allocate memory for that pointer, and then the destructor that's going to deallocate. Why? Because that's the best place to do it. Constructors when the object gets created, so that's the best place to start reserving your memory to use it. And then the destructor runs when the object goes out of scope or when you call delete on the object pointer. So like if I say delete A, it calls the destructor. By the way, you can also call the destructor explicitly, meaning I can literally write a line of code. If I have an object that's called T, and I want to call the destructor of the class. Let's say the class is actually called T type or something, or just TT. Here, to make it easier and not confusing, let's make the class called T, and then let's make the object name called T. I can, in theory, put a squiggly line here, put a T like this, and call explicitly a destructor, meaning that like this line of code will compile, and we'll literally call the destructor. But that's a really, 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 really bad thing to do. Like you want the destructor to be called automatically when the object goes out of scope. You don't want to call it yourself. If you do, bad things will happen. Yeah, I didn't notice that. Okay, big names with the T and the T. But yeah, okay. So yeah, be careful of calling the destructor explicitly. But know that it's possible. But if you ever see it, you should be scared as to why that's happening. Like why somebody would write that code. Probably there's a reason they're doing it. Because otherwise, like who would do that? It's like why would you do such things, kind of thing. But anyways, let's just go ahead and allocate and deallocate that pointer in the class, which is again I'm just kind of writing what I already have in the computer. From last class, which is just a new end, and then delete in A or PTR. Remember, when you call delete, you put delete and then you put the pointer. You don't need to put an asterisk here if this is a single dimension or something. And remember that if it's an array, you have to put the little square brackets, okay? But here it's not an array. I'm just saying because I know there were some questions on Discord over the weekend about that stuff, so gotta make sure you all remember that for the test. So yeah, this is good. And so now let's go ahead and make a class B. In class B, again, it's inheriting from A, but more than just inheriting from A, let's add something to it make it interesting. So, we're going to have a constructor and a destructor, and they're also going to be doing the same thing, but we're going to call this PTR2 like that. Okay, so now we have the PTR from class A, but we have another pointer from class B. So basically class B has two integers and two integer pointers, which are pointing to data, hopefully. And then the first class is just one, okay? So you have a system set up like this. The first question you should ask is, okay, if I make an object of B, so if I say BB, and then B goes out of scope, or if I do that, here, let's make it dynamic since I was just saying that. So I say B gets new B, and then blah, 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 there's some code, and finally it comes down to the allocated, so you say delete B, right? When you do this, that's when the destructor gets called. When you do this, that's when the constructor gets called, right? So the first thing you should ask yourself is, okay, if I do this, is there going to be a memory leak? Like, will calling delete on B guarantee that this delete runs too? And the answer is, well, it depends. Normally, it should work, but I'm going to show you a scenario where it doesn't work. And surprise, surprise, that's where virtuals will come to the rescue. Okay, let me show you when it does work. In this case, what I have right now, it will work because B is a pointer that is pointing to an object of type B. So the type of the pointer is actually the type of what it's pointing to. So that, you know, that's a very important thing, right? The reason why when I make int ptr equal to blah, 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 I'm telling the compiler, hello, compiler, how are you? I have a pointer that I'm making, and this pointer is going to point to an integer. And the reason I'm telling you it's an integer is so that you know that it is pointing to this type that has an integer is going to be 4 bytes, or a double going to be 8 bytes, or an object is going to be some bigger amount of bytes if it has other things inside of it, right? So you're telling that to the compiler so that it knows how to handle that. Okay? And normally it will not let you make a pointer of other type point to something of a different type because things get wonky. However, when you're dealing with void pointers in C and sometimes C++, I don't remember if that works in C++, but I think it does too, which is bad. You can technically have a void pointer, which is like an undefined type of pointer, which bad things. No, you don't want to do that. The point is, pointer, that when you're dealing with classes, it should stay the same way as it is here. I have a class B pointer, and it's pointing to an object of type B. However, it is legal in C++ to actually have a pointer of a parent class point to an object of a child class. So in theory, I could say a pointer, so I'm going to call it a, just to not be confusing, I'm going to call this W, okay? I have a pointer of class A as W, and I can actually make that point to my object at B. Obviously, you know, do that here so you don't have a, you know, because you call delete, but ignore the delete. You could do that. You could even allocate it directly there by saying new B. Or that make it uppercase. This is where things get a little messy because the pointer is like, yo, I'm a pointer and I point to objects of type A. But guess what? You're not really pointing to an object of type A. You're actually pointing to a different type, a pointer of type B. Things will work for the most part until they don't, which I'll show you. Okay? But let's rewind for a second. Before we even go with the messy stuff, let's go back to the basic example. So we have B allocates, so we have a B pointer that is actually indeed truly pointing to an object of type B. When you call delete, here's what happens. And I'll show you when we do the debugger because you can see the line by line. It's going to call the destructor B, and it's going to deallocate whatever is in B, you know, it's going to run the destructor code, which will deallocate the PTR2. And then it will automatically run the destructor of its parent. So it'll run this destructor, and we'll deallocate this pointer, which is good. We won't have memory leaks. So it's kind of like the opposite of the constructor. Remember when the constructor is run, so when I say, you know, this line of code here, in this case, the constructor runs first this piece here. You know, remember back in the day, this is a good review for the test. If I have something like this, I don't know, 100. This doesn't really make sense right now, but if it was a normal pointer, not an integer, let's just say it was some value. What this does is this initializes stuff, right? So remember, if you have a constructor like that, then that piece of code in between the colons and the bracket will actually run first when you call it. But after that runs, before it actually runs the body of the constructor, so before it runs this piece of code, it's actually going to run the constructor of the A class. So it's going to run this piece of code and then this piece of code. And then it's going to come back and run this piece of code. Okay? So, you know, if you look at it in order, it's going to, if you're making an object of B, it's going to run the initializer list of B constructor. Then it's going to run the initializer list of A constructor. Then it's going to run the A constructor body, so the code of that. And then it's going to go and run the B constructor body. And then you're going to be done. Okay? So that's for that constructor. So when you make an object of B, when you make an object, when you're deallocating an object of B, or when it goes out of scope, it's going to run the destructor of B and then the destructor of the parent. Okay, and again, this is assuming that A is parent of B. It's important stuff to know actually for the test. This piece here. Okay, so anyways, very cool. Works as you should expect. Everything is fine. Where things get messy is with the second example. But let's go ahead and just really fast throw this into code and confirm that it works as it should. Okay, so here we still have our class A with a PTR. So I am going to take this and copy paste it into a brand new class B that is going to inherit publicly from class A. And, you know, same constructors, same destructor, but I don't want to use the same variable name because that's going to cause issues. So I'll just PTR2. Okay, so bam, I have the class. So now let us go ahead and test it by making a pointer of each one and allocating them. And then maybe what do we do? Well, we can put something in there just to print it out immediately after. So we can say a PTR. Oh, that's cool. The autocomplete put the arrow instead of the dot for me. That was cool. Although I am, because it's a pointer and I want to set it, I am going to put an asterisk there so that I can then say like 20. Otherwise, it will yell at me. But will it do it again if I just put a dot instead of the arrow? Is it gonna do the arrow? Yeah, it automatically switches to an arrow. That's +1 win for VS Code, -2 for not having good compilers. But yeah. So anyways, you know, we play around with it. We can see out it immediately after. So in fact, here, let's do a quick see out function for both of these. Actually, just for B. Nah, we'll do for both. Yeah, we'll do for both because I want to refresh your mind on function overwriting. So if I go ahead and say a print function here, I can say cout ptr2 like that. Make it a void. And I can also, and this is something that I actually don't recall mentioning this, so I'm kind of glad I'm mentioning it today. But you can do this in the code. You can have a function name like print, like any function name you have in your class. This is actually really important. I can't believe I didn't mention this. Maybe you already saw it in the assignments, but when you have a class, when you have a parent class, and you have a function with a type, parameter, amount, you know, everything like that, and you inherit. So class A inherits, we forget about public and protected for now. If I write in the derived class the same function, return type, function name, and same amount of parameters, this will actually replace the function. So when I say b.foo, like this, it's actually going to run this code. Whereas if I make an object, you know, of A, let's just say here, it makes more sense if I say AA and then BB, so BA like that. When I do this to color code it, this is gonna run this code, and then this is gonna run this code. And it's just important to know that what you're doing is called overwriting. So you are overwriting a function. So the derived class is overwriting the parent class's function, which means you no longer have access to it. You have a new and updated function. And this is useful for things like print, because you may want to modify your print function when you're inheriting to add extra things. Okay? So I apologize for not mentioning that when we talked about inheritance, but there you go. Just tell me if that shows up in the test, actually. Because that'd be kind of scary if I hadn't mentioned that. But like I said, if there is a question in the test that I did not cover in class, just let me know. Write down that 4-digit code. And then if you truly didn't cover it, you will get free points. So the RNG gods will be on your side. You get free points, but I get deducted some points because other instructors are going to be like, lol, you didn't cover that, something. So, yeah. But yeah, so here in this case, you know, I have only PTR, and then here I have PTR's 1, and, well, it's not called 1, it's just called PTR, and then PTR 2. So this is an example where this is useful. You know, my print function in the base class is just printing out this pointer, but in the derived class, I want to print both the parent class's object, pointer, the parent class pointer, and also this class's pointer. So good example of overwriting, okay? Is there a way for an instance of B to access the A implementation? Well, I don't think so once you overwrite it. I don't think so. Like, I'm trying to think if maybe scope resolution operator could get you around that. But I don't know. I can try it. Like, you know, when you... Actually, technically speaking, there is a way. But it's bad. And that's the whole point, actually, of what we're getting to. Yes, there is a way. I will show you how to get that working. But it's actually what we don't want to happen, right? So yes. So it is possible. Obviously, the easy way is just don't name the two functions the same. But it is possible. And the way you do it, it's really bad, but it'll work, okay? So we'll get there, okay? Remind me in like 5 minutes and I'll show you that. But first, let's do the more basic example. Okay? So, this all should work right now as I have it. In fact, well, I'll put the deletes for now, but I do want to delete them later because otherwise the program's going to crash when I show you the bad things that are about to happen. But yeah, okay? So yes, hold me up to that for a minute. I like that actually. It's really nasty, but that's the whole point. Okay. So code works. I got no output though, because I forgot to call the print function. But yeah, so if I say a print, and then say b print, I'm gonna get some garbage for the second one because I never set it on this one. So let me just very quickly set it. But yeah, okay. Do your thing, compiler, please. Okay. Oh, ooh, damn. I guess I forgot to put the asterisk on these things. It's okay though, but you can see that it worked with addresses. So we have PTR. This is from A, and then this is from A and B. I guess this is a good point. It shows you the different memory locations because they're totally different objects. So that's kind of expected. Interestingly enough, they live very close to each other. That's cool. But of course, you know, we didn't want pointers there. We wanted actually to have the data. So there we go. There's more nicer looking numbers. Okay. Cool. Let's break the code, shall we? This is where things get nasty. So first of all, what I'm going to do... Oh, here. Last thing before I break the code. Let's actually not break the code yet. Let's very quickly run this to the debugger so you can see that the order of the constructor and destructors, just so that you can, again, refresh for your exam. So, yeah, let's just run it real fast. So, okay, we're going to call new on A. So you'll see that we go to the A constructor, run that constructor, you're done. B constructor is more interesting. First we go here, this is where we would go, but there's nothing right here, so we will kind of go skip that, and then jump A, then run this, and then go ahead and run the actual code of that constructor, and then run the body of B, so constructor, so run that. And then, bam, you're done, okay? And then if we go through those, oh, let's see which function this calls. It's calling the one from A, as we hoped. And then B is calling the function from B, as we hoped. Delete, this is interesting. So delete A, we'll just call the destructor of A, as you can see there. Deletes that, sets the pointer to null, you'll see that gets set to 0. Eventually, I guess. Okay, very cool. Why didn't it get set to 0? Whatever, don't worry about that. It probably did get set to 0, we can't see it. Anyways, the delete for B is gonna first call the destructor B, and oh, it's because it's the disk pointer that I'm looking at. That's why. If I see here PTR, yeah, see, set to 0 now. But if we look at A, that's still not set to 0. See that? So it's calling the destructor of B, and then it's calling the destructor of A automatically. It's setting it to 0. You'll see here, bam. I guess that's equivalent of 0. And then it goes back to the bottom of the B constructor. I don't know why, ignore that. And then goes to the end of that, okay? So just quick review of that, of how that runs. Okay, now let's break it. And I bet this visual stuff is fun. I like it. It's pretty fun to do, to break code. So let us go ahead and make another pointer, and we're gonna call this fake A pointer. And it's just a pointer, okay? It's just a pointer. Next, we're gonna delete. We're going to comment out the deletes for now, just because, you know, you'll see why. And now that we have our fake A pointer, let us go ahead, since this was mentioned, and use fake and set the fake A pointer to point to. Actually, first let's just make a point to the A. That should do no difference, but let's just baby steps. So let's go ahead and assign this to point to the A. So if we do that, and then, you know, we call, instead of A, we call fake A. This is just going to be the exact same. It's going to print 20, 30, and 40. Remove debug, and then yeah, we'll be good to go. Okay, yeah. But now let us switch this to B. So now we are making a pointer of type A point to an object that is not of the same type. It's actually the sun. So it's like saying we're making a dad pointer, not point to dad, but point to the kid. Okay? See what happens there. Let me put a breakpoint here. I hate it how it's just slower now when I'm about. I gotta restart the VM. Okay? It sees fake A. Who are you gonna call, basically? Who do you think is gonna call? It calls the A pointer. Sorry, the A print function. So there you go. I guess that answers your question. Is that right though? Is that this is where the part where, like, is this a good thing or a bad thing? Okay? In your case, I guess it's good because that's what you wanted to do. But in 99.9% of the cases, this is bad. This is real bad, because this is not an object of type A. This is an object of type B. Sure that an object of type B has all the contents of an object of type A in it, because after all it is inherited, but we should be calling the most updated function of this. This is just a harmless print function, no harm done. But it's just not, it's not the way. This should not happen. Bad things can happen here. We are basically fooling the compiler. Okay? We are fooling the compiler into thinking that this is not the right object. For something like a print, harmless. But now, let's go back and try to use the deletes. And instead of saying delete A, let's do delete fake A. Now this is really bad. When I run this, and by the way, you never got to see the fake A printout, actually just a thing, but you can believe me that it is if I do it right now. See, it's gonna go into A, it's gonna print it out, and it's gonna go back, right? And then for B, it's, you know, it's still okay. Oh wait, no, yeah. So these are both technically pointing to B's, okay? They're both pointing to the same object, actually, as you can see here. This A object has not even been used anymore. So I take this back, actually. Let's not even, this is really bad because we're deleting something twice, which is already bad in the first place. But let's for now comment out completely this A object. Just leave the B1 in there so that we can run Valgrind and take a look. So yeah, so we have an object of B, and we have a pointer of fake A pointing to that object. So we have, and then we're filling that data. We're going to call print on fake A and B, which are the same object, so you can see that they're different. And then we're going to try to delete B via the fake A pointer instead of trying to delete it with the B pointer. Okay? It's a lot of stuff. But let's just see what happens here. Okay, so fake A is fooled into thinking this is an A object, so it's calling the wrong function. It's calling the parent function of print, as expected. The B print, when it's actually a pointer of the right type, it knows that it's a, it's B, so it's like, okay, everything's okay, so it's calling that. So, as you already might suspect, when you're trying to call delete, the compiler also gets fooled. But here it's not harmless anymore. Here it's real bad, because now it's just going to call the destructor for the A class and then call it a day. And of course, if we run this with Valgrind, we can see that we have a memory leak because the destructor for B never got called. Of course, if instead of this, we do this, oh, don't run it there, run it on here, then there's no memory leak. Okay? So, we are essentially fooling the compiler into thinking that this is a different object. For your question, sure, I guess I answered it, that you can do it. But for every other case, this is really bad. So the question is, how can we tell the compiler, like, hey, this is actually not don't be fooled by appearances here. Like, actually find out if this is really an A or if it might be a child. How do we tell it to actually check that? Well, as the topic of the day kind of tells you, the solution to that is to use the word virtual. Okay? So we need to make this into a virtual class. And if we do that, then we are going to basically be okay. So this could be the first time I use virtual in like a year, but I believe you just put it there. Actually, I think we can make the destructor virtual. Will be okay. Yeah, okay. But you can also make an entire class virtual. I thought you put it there. Was it before class? We'll come back to that later. But hey, I think this will fix it. So what we're going to do is we are going to make the destructor virtual, but then we also have to make the print function virtual. Okay? Well, here, let's just make the destructor virtual for now, so that we can see if that solves the memory leak issue. So if I do that, like magic, well, actually, hold on. Let's flip it, because it's still using probably the, yeah, let's just do the key, so. Okay, so, like magic, the error is fixed. Let me remove the word virtual, just so you can see there's no quick sleight of hand happening here. Save that, compile, run it. You have memory leak right there. And of course, add virtual back in, compile, run it, memory leak gone. Okay, so no sleight of hand here. As you can see, adding this magical word fixed the problem. So how does this magical word work? Although it fixed it, but are we still having the issue with print? Let's see. Okay, so it's going to call fake A print, and it is indeed still calling the A the wrong print. So we can also fix that one the same way. If we do that, bam, now it calls the B one. So now it knows. Now it's like, it doesn't get fooled. We don't fool it that easily anymore. Okay? So this virtual thing is really cool. It's a little tricky to explain, so I'm going to do my best, okay? To do that, I need to define two terms. Where's my pencil? And also, somebody Google, okay, I'm going to Google because I am bothered. I used to know this by heart. It's so sad. Where do I put the word virtual to make the class? I could have sworn you could do that. Ah, okay. So I think you do it when you inherit. Let's try that really fast. So right here. Okay, you inherit virtually. Let's see if that does the same effect though. Okay, let's see which fake it. Nope, it actually called the wrong one. And it crashed because of the calling the wrong one for some reason. Okay, so that did not do it, so forget that. Let's just stick to the one that we had. Either way, this is probably the way you want to do it because you don't have to make every single function virtual unless you're Python. Then you do. It just happens for you automatically. But yeah, so let's kind of explain two terms to understand why this virtual magic is doing what it's doing, okay? And for that, the terms are going to be called compile time binding, and then you have runtime binding, okay? So, and also there's another term for this. So these terms are like, what would be an example? You know how classes, like parent class, you also call superclass, you also call base class, and then derived class, you also call child class or subclass. Compile time binding and runtime binding also share some of these terms, with other ones. So the other two versions you might see people use are static binding and also early binding. So all three terms are going to usually mean the same thing that I'm going to explain. So this one, and this one. And then the equivalent of these are runtime binding, dynamic binding, and late binding. Okay, so I guess early and late match, static and dynamic match, and then compile and runtime match. Okay, so I would stick to using one pair of these at a time. So go with like these pairs or go with the next one, but don't mix and match. Don't say like, well, this is static binding in comparison to late binding, because some people will be like, huh, wait, what? So yeah, but in case somebody else does that to you, you know what they're talking about. Just don't be that guy that like puts them on the spot and says like, oh no, you gotta use the two pairs that are right. Just nod and sigh in your head. Okay, so what this means, this compile time binding versus runtime binding, is that the C++, when you compile your code and it sees a member access operator, it says, okay, I need to decide what piece of code I'm going to execute based on what the user wants, right? So when I see something like a.print or a.print, whatever it is you're calling, what is happening is it goes and looks up this print function and it finds out what the code is and it links it at that time when you're compiling. Okay, that's how something like this will work in all scenarios, except when you're using virtual. When you're using virtual, as the name early and late imply, or runtime also implies, is that this connection between the object and the function that is supposed to be called for that object does not happen until the program is actually running. Obviously, this is a little bit less efficient because it has to make a decision at runtime, which takes time and effort. But you have the advantage of knowing at runtime that this is in reality this type of object. Okay, so at compile time, you know, right now what I'm writing in terms of code, it's obvious at compile time what the type of object is. It's called a fake A, but it's pointing to a B. The compiler could look at that and be like, "Yeah, you're not fooling me. This is a B." It doesn't, but it could in theory. You could write code that could do that. However, I could modify this example for a scenario where it wouldn't know until runtime. So let's just do that really fast. So it's always good to see actually. So, you know, you might be like, "I don't believe you," but I want to make you a believer. So let me very quickly back up so you can play at home with this version of the code before I modify it. There we go. And then I will be uploading them today instead of Wednesday because we don't have class Wednesday because we have the exam. So yeah, there will be no class Wednesday. It'll be you will have your exam during class time. So I will be uploading code today. Plus, if any of this code is useful for reference during the test, you're more than welcome to have it open. You know, might help. Who knows? Maybe it won't. I will open it at 5:15. So if you want to start a few minutes early, you can. Sorry, I lost my train of thought for a second. Okay. Yeah, so we have the classes here, and what I want to do was change the main. Yeah, main. Okay. I'm going to make a pointer of the base class, so A, and I'm going to call it mystery, and I'm going to put an if statement, or I'm going to put a cin statement, and the user is going to enter a variable, so int x, and I'm going to say cin x, and if the user enters a 1, so if x, or actually if the user enters to 0, then I'm going to allocate a B. Otherwise, so if they enter like a 1 or whatever, then I'm going to allocate an A. Once I do that, obviously I don't know whether it's an A or a B, so I can't really initialize these values here to 30 or 40. I can initialize the first one, so I can say something like, actually, you know, what I can do is I can initialize the second one in here, since I know that it's going to be called B, so I can do something like that. Yeah. Okay. Why are you complaining at me? Internet. What am I missing here? Oh, have I been writing too much Python code? No, this is okay. I feel like something is missing here, but I don't need those. Oh, I have been writing too much Python code. I do need those here. Okay. PTR2. It is called PTR2, is it not? Whatever. We'll see what the compiler says. I don't know why it keeps yelling at me. It's probably not right. But yeah, okay. And then we're going to call print on the mystery function. This should not be a semicolon. Okay. And then once we're done, we're going to delete it. Okay, so let's just compile it. Even though it's underlined, I want to see why it's complaining at me for that. Class A has no member. Name PTR2. So what? I know, but it's a pointer of A, but I'm referencing this pointer of B. I'm gonna have to show you casting for this. Damn. I wanted to show you the example, but it's gonna make me do casting for this to work. Although I was doing it before just fine. But oh wait, no, I was using technically a V pointer. Yeah, okay, that's fine. So do I want to show you casting first then? Okay, I'm gonna type the code that should be here so that this works. But I'll explain the casting part later, okay? So I'm gonna make a temporary B pointer. I'm gonna call this B pointer temp. And I'm gonna say mystery here. And now I'm going to say temp. It's that. And if it yells at me, then I'm going to do a dynamic cast. But hopefully it doesn't yell at me because I don't want to show you that unless I have to. Oh, it is going to. Doesn't even tell me what's up. Yeah. Okay. So fine. I'll do that. I'll do that. B mystery. Like I said, I will explain what that is doing if I remember how to do that. Why is it complaining about all this stuff? There we go. See? It compiled, but it's still underlining it in this VS Code. I hate that. Like, why is VS Code not like updating itself? After I compile it, it finally updated. Okay. So, all right. We're in business now. Ignore this line for now. I will explain it a little bit, but I will explain it. Yeah, I don't know. This does not happen like in Visual Studio in Windows for me or in Python. It's just happening in C++. I don't know why. Try C Lion. Might be better off. Oh wait, you are trying C Lion. Oh no. Well, I don't know what to say. But yeah. Okay. Anyways, the error, so that you're aware of, is trying to stop you from doing something bad. Although what I'm doing here is absolutely correct. But yes, I made another pointer. I copied this pointer to that just so that I can update it. Okay, but that's not the point of this. The point of this is that now I have written a piece of code where we won't know at compile time what type of object it is, right? As you can see here, we started with a pointer to A. And then depending on what the user enters at runtime, if they enter a 0, we're going to make an object of B. If they enter an A, if they enter like a 1 or a -1 or whatever, we're going to make an object of A. And so we need to be able to print the data. We need to be able to deallocate it safely. Okay? So even if we just like, for now, you know, I'm going to comment this out for a minute. Even if like PTR2 has garbage in it, that's okay. We can initialize PTR2 here by throwing in like PTR2. That's what I should have done instead of showing you the stuff. Let's put a 2 in there. Just so that it's good, okay? But here's the thing. I want you to see this happen live, right? When you're running the code, I'm gonna go ahead and put in a 1 for now. It's going to go here. It's going to allocate an object of A, as you can see. And then I'm going to store data. I'm going to call print. It's going to call the print on A. It's going to print it out. I'm going to call the destructor because it's running out of the scope. And then it's going to finish, right? So we're good. Let's start it over. This time, let's enter a 0. This time it goes into B. So this time it's an object of B type. So it's making B, A, all the constructor stuff we saw, storing a 30 into it, calling print. Now it's calling print on B. So it has to know, because we're using virtuals, that this is a B, because it's impossible for it to know at compile time, right? And same for delete. It has to know that it has to call the B delete, and then the A, instead of just calling just the A if it was an object of A. Okay? So as you can see, here's a very relatively simple piece of code that it's impossible to know which kind of object we're going to make, right? It's strictly dependent upon what the user enters. So when we think about this compile time, which is what we're talking about, and runtime binding, what we're saying is that by default, C++ is going to bind the function calls with the object. So it's going to be like, what is the type of object, so that I know which function to call, and it's going to make that decision at compile time. However, in the example I have right there, it's impossible to make that decision at compile time, because it's impossible to know what the object is going to be, because we don't know what the user is going to enter. In fact, it could be both. You know, if it could be a loop and I could just keep making notes of different kinds, etc., etc. Runtime binding, again, basically tells the compiler, like, chill out, chill out. We're going to make this a special function call, and we're going to add it to a special table that we're going to call the B table, or virtual table. And whenever any of these special function calls are called, we're actually going to have this lookup V table to know which function to call. So that's what's happening in this example when I added virtual. Instead of having that association done at compile time, it gets deferred to runtime. And at runtime, when you see the print or the destructor call, which are the two virtuals I added, it looks up in here and sees that there's two print functions. And it's like, okay, what type of object are you? Well, I'm being pointed, you know, like my pointer is of type A, but you know, that might not be my object. And it's like, I understand that. So what type of object are you really? And then it's like, well, I'm actually a B. Okay, so I'm going to call the print function from B. Or if it says, well, I'm actually an A. Okay, well, I'm going to call the print function on A. And same thing for the destructor. That is all happening at runtime, and that is how it knows how to pick the right function. Okay, so the solution to our issue is to essentially use virtuals. In C++, you have to do it. In other languages, everything is virtual, actually. Like I said, Python, it's just everything is virtual, so you never have to worry about this kind of thing. Virtual is going to be slightly less efficient because, again, it has to make the decision. It has to look at that table. If that table was massive, you can see that it will slow it down a little bit. So it's not as efficient, and it's also not as safe, because at compile time it can resolve these kind of issues, but at runtime there might be an edge case you don't cover and your program could crash. So it's not like, oh, virtual is always better, let's go with virtual. No, virtual is usually better, but then again, sometimes it causes issues. Okay, so that's what the static binding versus dynamic binding means, and all these terms, and that is how we solve this issue. So what is a class called that contains a virtual function in it? And the answer is what we have at the top, which is your abstract class. Okay, so when you have an abstract class, that means that you have virtual functions in it, essentially. Furthermore, there's a lot more things you can do with virtuals. So you could actually write a virtual function that is not complete. And I'm not going to get to that today. I'm going to get to that next time. But it's going to allow us to do some really, really cool things. Okay? So, you know, stay tuned for that next week, because there's no class on Wednesday. But at least we covered virtual destructors. So we kind of took care of that, because you saw that example here. Virtual inheritance, it's kind of what we were doing, but that's when you do the entire class. Remember the diamond problem? The diamond problem can be fixed by using virtual inheritance. So in this case, it really didn't do what we wanted to. But if we pull up the diamond code, Wait, that's Python. Which one of these is the diamond code? It's probably going to be like this one. Nope. Maybe this one. Nope. Nope. We're getting there, I think. Yeah, this is the diamond problem. Okay. So let's take that and let's just paste it here for now. Forgot the command is Control-Shift-K to comment things out, but I'll just delete it. I'll undo it afterwards. Okay, so here we have the diamond problem. Let's just see if it runs still. I don't know what last iteration of this was. Remove the pointers. So we have the two suns, I think. Yeah, we have this issue, right? With that. Control-K-U to comment. Yeah, you're right. It's a really useful command when you want to comment blocks of code. So here, if I go into here, into the dad and the mom, and I add the word virtual in both of these, I don't think I need to add it to the son. I just need to add it to these because the common thing they're sharing is the granddad C. So if I do that and I run it, you're gonna see it solves it. Here, let's undo it for a second. Run it one more time with the. Oh, well, hold on. I gotta undo it on both. Actually, I think if I do I have to do virtual on both? Maybe just one will I get away, but it's okay. Just don't do it on both for now. Oh, actually, you know what? This will be easier to see here, anyways. Laziness does not work there. I'm trying to find autocomplete. Okay, so now let's go ahead and add them in. Redo is not doing anything. Nice. Virtual. Okay, rerun it again. So, in the past, I think we contained two different values for mom and dad, which you can see here, sun C, and then sun C and sun C. So like, here, put them side by side. So, these two represent what the mom and dad contain, which is 22 each. And then well here, look at I think this one. So then I set the mom's C to 0, right? And then I can see that the mom and the dad both have the C from the granddad, right? So before, they both contain 22. But I changed one of them to 0. And so you can see when I print them out both again, that one of the C's has a 0 and one of them has a 22. This proves to me that both variables are different, but still have the same name, which is why I have to use the scope resolution operator. Compare that with the virtual version of this. And you can see that I start out with 22, but when I set one of them to 0, it sets the second one to 0. See that? So I have two zeros here versus here I have a 0 and a 22. So that is because they're not actually different variables. They're the same variable, which is what we want because we only want one copy of it. So using virtual inheritance, I am able to solve this issue with just adding the word virtual. So if you need to fix it for functions, you have to manually add it for each function. If you need to fix it for variables with the diamond problem, then that's when you do the virtual thing there. Now I guess I remember by saying this, but yeah, before I didn't remember either myself. So yeah, just revisiting that example is an example. It's just kind of good for that. Okay, so let's just let's bring back our code. There we go. Welcome back, code. So that's what I mean when I'm talking about virtual inheritance as well. So we got 2 minutes left. I don't have enough time to talk about the type of casts that we're doing, static and dynamic. But what you saw here is a dynamic cast. So when you're trying to take a pointer of one type and make it into another type, you know, well, think back of 135. When you have a variable like a float, you know, so you have a float, you have like float, you know, f is equal to 4.5. Well, actually, if you use the 4.5, this is technically coercion, right? Because this is a double and he gets coerced into that. Similarly, if I say int g gets 22.3f, this is a float. It gets, you know, g only gets 22 out of that because it gets coerced, right? That's called coercion. You learned that concept in 135. You also learned that if you would like to store a, you know, like into the integer, this float that we have, if you do this, this is again coercion. So these are all coercions, but you can also do what's known as casting. To cast in C++, what you do is you write g equals static cast, and then you put the type of what you want to cast to, and then you put what the variable or data is that you're casting. Okay, that's one way to do it, and I believe the C way is you would write that. I think it's just like that. Some languages do it like this, so I might be mixing them, but I believe it's the top one. Okay, but that's more of like the C way. This is proper C++, like strong way. Okay, so that's casting, that's coercion. Casting is explicit, coercion is implicit, meaning that casting you do yourself because like you want to do it, coercion happens automatically. So just like you cast like integers to floats or floats to integers, whatever it is you're casting, you can also cast pointers. So next Monday, I will go ahead and talk to you about what that is, and that will explain what this type of cast is, because there's more than just static cast. There's dynamic cast as well, and there's reinterpret cast, which you don't really want to use, but I'll talk about it too. So there's still a lot to talk about with virtuals. We're just getting started on it, but hopefully between that and the fact that we talked about things like inheritance, it's a good review for the test. So having said all of that, we are now out of time, and so this is where I leave you. Wish you the best for the exam. You know, don't try your best, but don't stress it out too much, because that won't help you at the end of the day. Just, you know, do your best and move on with your life. It's not the end of the world. If you do good or bad, it's just part of life. So, yep. All right. So I will thank you if you do good in the test, because that'll make me look good. So then you'll get my thanks. So yeah. All right. So good luck, and like I said, if you get stuck on the test, DM Discord me or the TA, or email us, and we'll get to you ASAP. We'll be monitoring our emails. I have the 302 test right before it, so I will just be monitoring all day, email and Discord. And if not, then, you know, just do your best. Write your assumption if you make any variables that might be mistaken, and whatnot. So, but yeah, you know, you should be fine as long as you've been doing good in the assignments and understand the material. Then I think that this will just kind of be a continuation of that. It's not going to be a surprise. Like I said, if you do find a question that you have no clue, you think that we didn't cover it, don't freak out. Skip it for now. Do the rest of the test. Come back to it. If you still think that this question didn't cover it, just you know, write on your answer that we didn't cover it, and then also after the test finishes, send me an email, or actually send the TA an email. Send both of us an email, and then mention it. That way you don't waste test time on it, and you won't get punished for it. Even if you forget to do that, as long as you write a comment on the test, when the TA is grading it, she'll know. Okay? I believe it's, don't quote me on this, I can't remember for sure. I think it's 10 assignments total. I have a sheet that says all the topics of the assignments. Just remind me next time, and I'll pull it up. But yeah, so about 10. But there's also the extra credit one. That's a Halloween one. So yeah. Or you could just do the extra credit and make up the points back that way. And the extra credit is pretty fun. So it's Halloween themed. Very spooky, yes. It's a little bit cringy though. When I made the video, I was looking at it again. I'm like, oh no, why did I do this? But it's okay. So that'll be released later on this the month when we get closer to Halloween. Okay. All right then. Yeah. Just let me know if anything comes up. All right. So otherwise, I'll see you guys next Monday. Don't show up on Twitch on Wednesday. We're not streaming the test taking session. Don't stream your test, actually. That's kind of important. Don't stream it. And then after the test finishes, keep radio silence on the test probably until, like, I would say Friday. Because remember, even though the questions are random, there is still a possibility that two of you could get the same question or in another class. So you will be amongst the first to take the test. Well, actually, no. The people that have the class early in the morning will have the test first. But, you know, all the people that have the class on Tuesday, Thursdays will take it on Tuesday, Thursdays. So radio silence. Don't leak the test. Don't sell the test. Don't do anything with the test after you're finished. And then, yeah. All right. See you all later, and the best of luck.